Alright, this video is about finding a volume of different 3D shapes. So to get started, I think we need to be able to identify different shapes and the proper way of naming shapes. So I'm going to draw a few shapes and give you some tips on how to name them properly. Okay, so we'll start off with a type of shape called a prism. Okay, now a prism can be any type of shape. We can have rectangular prisms, triangular prisms. We can even have circular prisms, but we have a special name for those. So basically the idea of a prism is that we would have a shape, and that shape would be the name of the prism. So we're going to start with a rectangle prism. Okay, the prism is a 3D shape that has a rectangle as its base. Now the base is the side that has the exact same side opposite of it. So if I drew it like this, a rectangular prism is kind of unique in that it has three different sets of bases. But I'm going to color in one set of base. I'm going to just draw in the dotted lines in the back to help you see the three-dimensional part of this. I think I've got all of them in there. Okay, and those I'm going to color in the shapes that I'm going to identify as the base. Okay, so we're going to use this front one. Okay, this front one as the base, and then this back one. Okay, and the important thing is the sides that you choose for the base must be exactly the same, so in order for it to be a prism. So I've got a rectangular prism here because the base I've chosen is a rectangle. Okay, I will show you a triangular prism. So we've got a triangle, okay, and then it is a three-dimensional shape. Okay, so to help get an eye for that, I'll put the dotted lines in again. Okay, and I will color in the sides that are that we refer to as the base. So this triangle in the front and this triangle in the back. And again, those triangles need to be the exact same size in order for it to be a prism. Okay, I will show you the circular prism as well. Okay, and a circular prism has a unique name to it. It is called a cylinder. Okay, and again, the bases are the circle at the bottom and the circle at the top, and those circles are the same size. Okay, the reason why I'm showing all of these prisms at once is because we can determine the volume of them in the same way. Okay, in the past we've done units on finding the surface area of different shapes, and we've had a bunch of formulas that help us determine what the surface area is. So I'll jot down a few of those formulas and hopefully they're familiar. So the area of a rectangle. Okay, hopefully you remember the area of a rectangle is the length times the width. Okay, an area of a triangle. Okay, hopefully we remember. It's the base times the height of the triangle, and then we divide that by 2. Okay, and finally the area of a circle is equal to pi times the radius of the circle squared. Okay, now that we recall those areas of the bases, we can very simply find the volume of each of these different shapes. So the volume, the overall general formula for the volume of a prism looks like this. Volume is equal to area of the base, so we need to make sure we've recognized the right one, and then we multiply that by the height, or depending on the way it's positioned, maybe it looks more like the depth, basically the other dimension. Okay? So that's the overall formula. If you remember that formula, you can do any of these volume questions. There are complicated formulas that you can derive for each of these different shapes. I prefer to keep it simple and just remember one formula like that. So let's show what that actually looks like for each of these different shapes. So I'll do a slide for each of them. Okay, so we will start with a rectangular prism. Okay, so the rectangular prism again looks something like that. Okay, and I'm going to put some dimensions on it. So this front surface here along the bottom is going to be 4. We'll say that that's 4 millimeters. All of these will be in millimeters. Okay, this one here will be 2, and going back will be 8 millimeters. Okay. Okay. So remember, our overall formula is volume is equal to area of base times the height. Okay, so in this case, we need to identify what the base is, and so if you remember back to the last slide, we said the base was this rectangle. In this case, it doesn't actually matter. You could use one of the side pairs or the top and the bottom pair as well, but I'm going to identify these as the base. So how do we find the area of that base? Well, that's a rectangle shape, and we know that that is length times width. So we see that the length of that rectangle is 4 and the width of that rectangle is 2, which means that the area is equal to 4 millimeters times 2 millimeters. Okay, and then the rest of our formula is times the height. So we'll just simplify that out. 4 times 2 is 8 millimeters. And recognize here that millimeters times millimeters makes that millimeters squared, which makes sense because areas are always in squared units. We're multiplying that by the height, or in this case, because it's kind of tipped on its side, the height is the other dimension, basically the distance between those two bases that are identical. So in this case, it is the 8 millimeters. So now I've got volume is equal to 8 millimeters squared times 8 millimeters. So 8 times 8 is 64. And we're going to multiply the units as well. Millimeters squared times millimeters makes it millimeters cubed. And you'll know that you did it right then because millimeters cubed, or a cubed unit, is always going to be the unit for volume. So this rectangular prism has a volume of 64 millimeters cubed. Let's move to another example. Okay, this example will be for a triangular prism. So I'll quickly draw a triangular prism. Okay, and we'll give it some dimensions. We'll say that the base of this triangle is 2. Okay, I won't put the units on it. We'll say that all the units are in millimeters again. Okay, the height of this is, okay, so remember height is perpendicular to the base. Height is also 2. Okay, and the depth, or the length of the whole prism, we'll say is 6. Okay, so again, we want to find the volume of this. So volume is equal to the area of the base times the height. Okay, what is the base? The base is these triangles. Okay? So if we color that in just to see it, okay, that triangle and that triangle, excuse me, is the base. So the area of the base triangle, we remember, is base times height divided by 2. So base times height divided by 2. Now don't get confused. These two heights that we're talking about here are, they mean separate things. The height, this is, the first height here is the specific height of the triangle. Okay, so we plug in what we know. The base was 2, the height was also 2, and then we divide by 2. So 2 times 2 divided by 2 is just going to equal 2. Okay, and then we're going to multiply that by the other, the distance between those bases, which is 6. So volume is equal to 2 times 6, or 12. We said that's in millimeters, and remember that the unit of volume is millimeters cubed. Okay, that makes sense. And we'll do one of the cylinder as well. Okay, so example of the cylinder. Okay, try to draw a nice cylinder here. Okay, and this cylinder has a radius of, let's say 2, okay, 2 millimeters again, and the height of this is going to be 4 millimeters. Excuse me. So again, we go, the volume is equal to the area of the base times the height. Okay, this time we recognize that the base is these circles, which means that we need to use the formula for the area of a circle, which is pi r squared. And then we're going to multiply that by the height of this cylinder. So pi times r squared. R we said was 2, so r squared means 2 times 2, or 4. So we have 4 times pi. If you want to multiply that out, you can. Pi is, we can use the value of 3.14. But you could just leave it as pi as well. So 4 pi times, and then there's that height that we're multiplying it to. Okay, so volume is equal to 4 times 4, which is 16. And don't forget that pi that's left there. And the units are always a cubed unit, volume cubed. Okay, I hope that is helpful.
Made with Doodlecast Pro.